All right, so stoichiometry. Stoichio means element, and metry means to measure. Okay, so you're measuring elements here, essentially. So chemical reactions are going to keep going as long as there's reactants there for them to work with, okay? Reactions, so this RXN here is the abbreviation for reaction. If you don't want to write out the whole word reaction, that's what we do, okay? Reactions will stop when you use up those reactants, when you don't have any more left, okay? You have a fire, you know, a campfire, and you can keep that going until you run out of wood. But eventually you're going to run out and the fire goes out. So stoichiometry allows us to predict how much products are going to be formed, or if we know how much product we need, we can look and see how many reactants we're going to have in order for that to occur. We're going to talk about these mole to mass relationships. We already started to look at that in chapter 10. And stoichiometry then is going to allow us to be able to move from those reactants into the products and vice versa. You have to have conservation of mass, which means that you have to start with a balanced equation. So since matter can't be created or destroyed, you have to have a balanced equation to start with. Does that make sense? All right. We have been tasked with making breakfast specials. Okay. So one breakfast special here. So we're going to have a breakfast special that's going to consist of 2 eggs and 3 pieces of bacon. Okay. So that means that we need to start out with 2 eggs and 3 pieces of bacon. Yum. All right, so this is my balanced equation. I've got 2 eggs on both sides. I've got 3 pieces of bacon on both sides. All right. So if we're looking at this, did they tell us how many bacon specials we're supposed to make?
No.
Oh, okay. Well, how many people we got in here?
7. I don't know.
We have 12.
12. So we need.
11.
Did you get Austin in there?
Yeah.
Okay.
What? We don't have 12 people.
Did you count Austin?
I thought we were only counting children.
Oh, I don't get to eat?
I know you do.
That's nice. All right, so we can use our stoichiometry to figure out how much of these things we need to start with to be able to make 12 breakfast specials. So like I was telling you last week, when we do this, we're going to start with our number here. If we know our products, we're going to go up into the cloud. When we go into the cloud, we have to go through the coefficient, which means we're going to divide. So 12 divided by 1 is 12. Okay, so here's my cloud. And now I'm going to bring that number down. And when I go down through the cloud, I have to multiply. So 12 times 3 is 36. And 12 times 2 is 24. Okay, so in order to make 12 breakfast specials, I'm going to have to start out with this much material. Does that make sense? When you're done, you have used up all of these, so you have none remaining. And over here, you would have started with none, and you would have added 12. Everybody cool with that? All right. So when we are looking at this, we have to start out with a balanced equation. So the mass of the reactants has to equal the mass of the products. Okay, so if we look at this, we can figure out what the molar mass of each of these is. So for iron is 55.8 times 4. So that's 223.2. Here we have 32 times 3, which is 96.
I'll play it.
Oh, dang it, I had 810.
319.2. Okay. And then
Why couldn't you be a minute faster?
if we add up our products, they add up to be the same amount. Okay, questions on those?
319.2 what? Elephants?
Grams per mole. Grams per mole.
Thanks, Lippy. Makes sense now.
You should have tried to make it so the equation was that it equals 304. That would have been cool.
Why? 304.
Yeah, because that's the real number. Not even the cheesy moment.
Okay, so now we're going to move in and we're not going to be talking about food anymore. We're going to start talking about actual moles and that sort of thing. Okay, so here is a huge key to your success. Okay, in these boxes here, you need at least 3 sig figs. That means that if you have this number, you only have how many sig figs? 1. You need to keep that going. You need 2 more digits beyond that. So be careful. Be very, very careful with that. If you don't keep at least 3 sig figs in there, your numbers are going to get dramatically off compared to what the correct answer should be. Then in these boxes, and this won't make a difference today, but tomorrow it will. These boxes can only contain moles. So if you are given a mass in grams, you have to convert those grams to moles. Only moles in the holes. That's where moles live, right? Moles live in holes. Only moles in the holes.
Holes live in holes.
I don't think you need to write that down.
Live in
Yeah.
holes.
What are the equals?
Hashtag moles in
All right,
holes.
so I'm going to, oh, and I still didn't fix this. Dadgummit.
Cool. If anything I learned today, that's going to be my new, that's what I'm going to learn.
Moles in the holes.
Yeah, my video.
All right, you need to add another line here. You'd think after this many years I get this stupid thing fixed. All right, so I'm going to write my equation down. I'm going to write 2K plus 2H2O. And you need to make sure your equation is balanced when you write it in here. 2KOH plus H2. So your first step is to balance your equation. They've already done that for you, so that was nice. Then we've got determine the moles of hydrogen. So we're trying to figure this guy out when we use 0.0400 moles of K. Now, at this point, we're going to assume that we have an excess amount of water available. So XS means excess.
Who was right today for a different person?
What I said.
Sir?
I just said he.
Oh, that's true.
That did not come from attendance, did it?
No.
He made it himself.
Well, Well,
Actually, you brought it up.
if the slip comes from attendance, then I don't have to do anything about it. But if it comes from some other person, I don't know who that is, well, the handwriting is, anyway, if it comes from somebody else, then I have to change it myself. All right. So we're going to assume that we have an unlimited amount of water. So I'm going to call that excess. Okay. Now I'm going to take my number here and I'm going to go up into the cloud. When I go into the cloud, what do?
Multiply.
I divide. To go into the cloud, I'm going to divide.
Oh, yeah.
So 0.04 divided by 2 is 0.0200.
I don't know what doing. I do, but
All right. Now, to find out how much hydrogen I need, I'm going to bring that down through the cloud. When I bring it down, now what do? I multiply. I'm going to multiply by that coefficient. This happens to be 1. So we need to add oops, I can switch my other pen here. I'm going to add 0.0200 hydrogen. So that means that I should form all the hydrogen here if I use up all of that. Okay. Now, I started out with 0 hydrogen. We can figure out how much this guy is going to be because when we come down through, we multiply. So we would have started out with 0. We're going to add how much?
0.04.
0.0400. How much water are we going to need? Well, we are starting with excess, but out of that excess amount, how much are we going to need? 0.0400. We're still going to have an excess amount. We don't know how much it is, but we're going to have that much left over. Here, we're going to use up all of this, and we're not going to have anything left over. Okay, see how those tables work?
I do.
All right, let's try another one.
Oh, so we just can't solve for excess?
No, you don't know how much that's going to be. You just got extra amount left over. We will eventually get there, okay? But just not today.
Okay.
It's going to be, I think it's Wednesday in here.
Okay. Oh, we have a sugar class?
All right. So here we have, and I forgot. I need to.
We got another box.
Yeah, I did.
But you found that out and did the wrong one.
All right. So I'm going to react C3H8 plus oxygen. That is going to produce CO2 and H2O. First thing I have to do is what? Balance my equation. Balance that equation. Go.
Double. Yeah.
All right. You got it balanced?
Yeah.
Okay. All right. So I'm going to put this in. They told me that I have 10 moles of this guy. They didn't tell me how much oxygen I've got, so I'm going to assume that I've got an excess amount. And I'm not starting out with any products to begin with. All right. Now, when I go up into the cloud, I'm going to divide. So my cloud is going to be 10.0. And then I'm going to go through here and I'm going to multiply as I go down. So see if you can figure out what all of the boxes for the change line are. All right, so I'm going to use up all of this and not have any left over. Here, I'm going to need, oops, that shouldn't be a plus, that should be a minus. I'm going to need 50 moles of oxygen, leaving me with an excess amount. Now on this side, this is going to be a plus because I'm making this stuff. So I'm going to add 30 moles here. And I'm going to add 40 moles of water. So the question asked how many moles of carbon dioxide. You're going to make 30 moles of carbon dioxide.
They're not vinegar.
What are they?
All right, we have sulfuric acid being formed when sulfur dioxide,
I don't know.
sulfur dioxide,
SO4.
oxygen, and water form sulfur dioxide. All right.
Acid?
Sulfuric acid is formed
Oh yeah, you said something about
when sulfur dioxide, oxygen, and water
that.
react. Okay, I've got to balance here. So I've got 2, 4, 5. That's not going to work. So I'm going to double. I'm going to have to double this to start with. That's going to give me 4. So I'm going to put a 2 there. I need to put a 2 there. So that's 4, 5, 6, 7, 8. There we go. 2 sulfur. Yep, I think I got it now. Okay. All right. So we are starting out with 12.5 moles of this. We're going to assume that we have an excess amount of this and an excess amount of this. So see if you can solve for the change and the after line for this reaction. Austin, are you done, hon?
Mm-hmm.
Can you run this to Miss Hanson? Tell her it's from me. She's in L005. If she's not there, bring it back.
Oh, we actually I know.
So my cloud is going to be what?
6.25.
6.25. Good. Okay.
Using a balance.
Well, that's fine. All right. So I'm going to, that's my cloud. So over here, I'm going to use 12.5. I'm not going to have anything left over. Here, I'm going to use 6.25, and I'm still going to have an excess amount left over. Here, I'm going to use 12.5, and I'm still going to have an excess amount left over. Here, I'm going to make, so this is going to be a plus 12.5, and end up with 12.5 moles. They asked us how many moles of oxygen are needed. That's going to be right here. That's how much oxygen you need. So you're going to need 6.25 moles of oxygen. What you think?
Is that it?
Doable? That's all we're going to do today for these. I think that's, yeah. So your homework tonight then is 11.2. For those of you who have not turned in your mole lab, today is the last day for those. And then I'm not taking them. So make sure that if you don't have that turned in to me, you get that taken care of. Because otherwise, yeah, it turns into a pumpkin, you guys.